So in problem 6, we're going to be integrating 4 times the cosine of 3x dx. Now our first step is to identify u. We're going to be using u substitution. In this case, our u is 3x. Now we need to find du. Du is the derivative of u. So instead of looking at our integration here, we're going to just take the derivative of 3x. So du over dx is 3. Du equals 3 dx. Now the first step that I'm going to do, I'm going to take 4 and put it out before the integration sign. So I'm going to say 4 times the integral of cosine of 3x. And now to get it into the reverse chain rule form, we can multiply this times 3 dx. Now, for us to do this, we can't just multiply it by 3 dx. We have to make it so this 3 somehow gets canceled out. This 3. So now we can use this 4 to help us, and we can say 4/3 times 3 really doesn't do anything, because if we look over here, 4/3 times 3 equals 4. Therefore, we can do that. It's plausible. So now we have 4/3 times the integral of cos. Now we can substitute 3x with u. Remember, u equals 3x. So the cos of u times du. Our next step is to integrate this. So we're going to say 4/3 cos of u. And our du gets canceled out. So the derivative of cos, the antiderivative of cos is sine. So we're going to say, I don't know why that happened. So we're going to say 4/3 times the sine of u. Now we're almost done. We have one last step. We need to plug a numerical value, or 3x, back in for u. So our ultimate answer is going to be 4/3 times the sine of 3x. Now to check this, we can take the derivative of 4/3 sine of 3x. And I think that it's going to come out to 4 times cosine of 3x dx. Oh, and don't remember your plus c.
Okay, so problem number 3 is another indefinite integral problem, and so I'll write it out. It is the integration of the square root of 7x plus 9 dx, of course. Now, the first thing that we want to look at is our u value, and we want to allocate a certain u value. So we look underneath this radical, and really what this root is x to the 1/2, and so underneath that root is where we should find our u value, because that's g of x. So we're going to take this value out, and we're going to say u equals 7x plus 9. Now, from this, we need to find the derivative. We need to find du dx, because we're going to be using that later in the integration. So du dx is the derivative of 7x plus 9. So this isn't a very hard step. It's 7. 7 is the derivative, because the derivative of 7x is 7, and 9 cancels out. So now we need to find du, because that's what we're going to be using. We're not going to be using du dx. So du equals 7 times dx.
Okay, now that we have the function in terms of u, we can rewrite this equation as the integral of the square root of u and dx. Since 7x plus 9 is equal to u, we can substitute that in. And since that we also have 7 for du dx, we can put a 7 in as a coefficient, but since we added the coefficient, we get to multiply by the reciprocal on the outside. So it's 1/7 times 7, so that will cancel out and become the original function. And now, since we have 7 dx, that also equals du equals 7 times dx. So this equation also can be written as 1/7, because that carries down, times the radical u times du.
So we're going to take the antiderivative, or sorry, we're going to integrate this function. So we have 1/7 integrated, and to make it a little easier for yourself, we're going to write root u as u to the 1/2. Because when we take the antiderivative of that, it's going to make it a lot easier. So when we actually integrate it, the integration sign goes away, and it's 1/7 times, now the antiderivative of u to the 1/2 is 2/3 u to the 3/2. And the du goes away. And now we're just going to plug our u, 7x plus 9, back into our function. So we're going to multiply 1/7 times 2/3, which equals 2/21. Yeah.
That's weird.
That wasn't supposed to happen, but times u, which is 7x plus 9, all to the power of 3/2. Now this is our answer, but we can't forget that we need to add c, because this is a constant that gets added.